So we're back for LRAM8. So we're going to do y equals x squared plus 3. Similar problem that we've done already. From x equals 1 to 5, same interval. But this time, instead of using 4 rectangles, we're going to kick it up to 8 rectangles. So let's take a look at the rectangles in the diagram. So the first rectangle there in a left-hand approximation method is drawn so that the left-hand side of the rectangle is touching the curve y equals x squared plus 3. The second rectangle is drawn in a similar manner. The third, the fourth rectangle, and onwards. And you don't need to draw in every rectangle in the diagram. Just a few rectangles will give you the feel for how to fill in your K and X chart. So the first thing you want to do is you want to find the base of each rectangle. So that would be the highest x value minus the lowest x value, 5 minus 1, and then divide by the number of rectangles. So 5 minus 1 is 4, divided by the number of rectangles, which is 8, gives you 4 over 8, which is 1/2. So we know the width of each rectangle is 1/2. So when we start to plug in our chart, and remember K values stand for rectangle number, K equals 1, 2, 3, etc. We now want to fill in what the appropriate x values would be. The first x value would be right here at x equals 1, since the left-hand side of the rectangle is hitting the curve. But now, since the width of each rectangle is 1/2, the x value that we plug in to find the height of the second rectangle is 1.5. And then moving over one more width of a rectangle brings me to an x value of 2 for the third rectangle. So filling in the chart for the x values, we get 1, 1.5, and 2. So the reason we do the chart is so that we can later convert from x's to k values when we're trying to evaluate the area using the sigma notation. Keep in mind that these charts will always create a linear equation in the form of y equals mx plus b. The m is the slope. The slope is going to take on the value of the width of the rectangle, or our delta x. Okay? So let's take a look at what equation we'd write here. We would write the equation x equals 1/2 k plus 1/2. Now, how do you get that? What you can do is you can determine first that you know the slope is 1/2. So instead of the m, you put 1/2. If you look at the way we have our chart set up, normally the first column is the x value, so instead of x, we'll put k. The second column is the x value. Normally that's a y value, so we interchange the x where there would normally be a y. The last part of this is what number to add or subtract. You can find this by plugging in k equals 1 into the formula 1/2 k. So half of 1 is 1/2. What number do you have to add to 1/2 to make the final x value of 1? And the answer is 1/2. Now that is the correct equation, but for purposes of simplifying in the equation, I always suggest to write this as a fraction, 1 fraction. So for example, since they both have a denominator of 2, 1/2 k is k over 2, and 1/2 is just 1 over 2, we can rewrite this as k plus 1 over 2. So that would be the format that I would use. Moving on to my sigma notation, note from the first two problems the slight change. K equals 1 to 8 as opposed to k equals 1 to 4 when we did the problems with 4 rectangles. An area is still base times a height. And at this point, we are going to plug in. The base of each rectangle is 1/2. The height can be found by x squared plus 3 because our equation for the curve is y equals x squared plus 3. But, as we've stated before, we don't want x values. We want to transfer it into k values. So right here where we see this x value in the equation, we're going to replace it with k plus 1 over 2. So by doing that substitution, the k plus 1 over 2 is squared, plus the 3, and we have the half out in front because that was the base. So now at this point, we need to expand out the k plus 1 over 2. remember, a common mistake would be to forget to square the 2 in this fraction. So square top and bottom. So we have the 1/2 k squared plus 2k plus 1 over 4 plus this 3. Please note that this expression x squared plus 3 was in parentheses because that entire expression was the height. So while working through the problem, be sure to keep this whole part of the expression in parentheses and distribute the 1/2 to the whole expression there. Combining some things here, in order to add the 3, we'd have to get a common denominator. So this becomes 12 over 4, and 12 over 4 plus 1 over 4 is 13 over 4. So k squared plus 2k plus 13 over 4 still times the 1/2. So at this point we could distribute the 1/2 to make this whole fraction over 8, and at this point we want to break apart the fraction. So k squared over 8 is really 1/8 k squared. 2k over 8 is the same as 1/4 k. And finally 13 over 8. So break that apart into each its own sigma, and then we're ready to evaluate. So 1/8 times k squared, n plus 1, 2n plus 1 over 6. 1/4 times n plus 1 over 2 plus sigma times constant, or sorry, constant times n. So that is 8 times 13 over 8. Evaluate each part of this, 25.5 plus 9 plus 13, giving us a final answer of 47.5, which would now be a better approximation than if we were to use 4 rectangles. Still an underestimate, but a better approximation.